Now, so I'm going to do a wrap-up recording on this example here, numerals to text. Now, as I said, this is quite a difficult program, quite a lot of complexity to it, but you can split it into three major sections. The first one being, can you separate out, or can you make a single digit, such as the digit 8, can you turn that into the writing E-I-G-H-T? Okay, so most of you, I would expect, should be able to do that at this stage. Then take a number like 895, can you separate that into the 8, the 9 and the 5 and separate those out into giving the result 895. Okay, that's the next level of difficulty, being able to do that. And the final level of difficulty would be, can you take a variable length number? Okay, in other words, that it might not be 895, it could be 4356, so that then has 4 digits to it. So could you deal with that situation? So as I said, there are 3 levels of difficulty. If you're ever faced in an exam with any question that you get, I normally have it set up in such a way that you know, there are marks for each different section, and obviously the final marks, while still being worth the same amount, are much more difficult to get, because obviously it becomes much more difficult to get over 70% than it is to get over 40%. Okay, so we'll start into the program and we'll do the first part of it, which is we will turn an individual number into the letters of that number. Okay, so I'll just pause while I write the bare bones of the program. Now, so we're going to take in a number, which is an integer, right? So an integer, and we'll just call it num. Actually, I'll call it input, just so that we remember what's the input. And what I will do is I'll create a separate one called num, and that's more for later on, that I want to be able to separate my input into several different numbers. So that's the only reason that's there. We don't even there's no other reason for it for the moment. So printf please enter a number /n. Taking it in as an integer, and it's going into input. Now, what I'm going to do immediately, I'm just going to say num is assigned input, and then use the num variable. As I said, later on that'll come in handy, because I'm going to be separating input into several different numbers. So what I'm going to use here is I'm going to use a switch statement. As we saw in the previous example, obviously the previous example was quite a simplistic one. This will be a little bit more difficult, but nothing too bad. So switch num. This time I'm dealing with numbers rather than characters, but other than that, it's the exact same. Now we have a goodly many cases in here. So I have case 0. Again, I'm going for the semicolon. I'm so used to doing it, but it's not. P-R-I-N-T F O-N-E. I'll just put a space after it rather than putting a /n, in case we want to put several of these in a row, and a break statement. Okay. Now I've got to do this for all the different cases. So okay, so just be changing these. I went and put 1 for 0. Okay, so 0, 1, 2. Remember to put the number 2 in. Put the number 3 in here. Okay. Number 4. Okay, so I think you can see where I'm going with this for the moment. I'm just going to pause while I finish off these. And that's 9, which is the last one. I'm going to put in a default case just to be safe. So default case, I'm going to say printf not a number. Break isn't really required down here, but I kind of put it in just to keep it constant. Okay, so we can see here now we've got the switch num, in comes the num, and it gets separated into the 1s, the 2s, the 3s, and so on, and prints out that number. And that's pretty much the first part of the job done. I'll just save it here, file, save as, and I'm going to call it num2 see. Give it a run. Okay, oh yes, I put in an extra brace where I didn't need it. I'll just get rid of a lot of this white space here. Okay, please enter a number. I'm going to enter the number 9, and it's printed out a 9 for me. And I'll run it again. Print out the letter 3, it's printed out THREE. So that's the first part of it done. Now, the trouble with this is that if I type in the number 895, it says it's not a number, and that's because 895 is not the same as 8. And so what we need to be able to do is to separate that out. Okay. So what we're going to do is, once again, I'm going to tab everything in one place because I'm going to put something around this, and what I'm going to put around it is a while loop. So that loop is going to run a few times. While, again, we'll look at what I'm going to put in that while in a moment. Now, if we take the number 895, what I want to be able to do is I want to be able to separate out the 8 on its own, and when I get that 8 on its own, I want to be able to put it through as num down through my switch statement and print out the 8. I then want to be able to get the 9 on its own and then just print out the 9, and then I want to be able to get the 5 on its own and print out the 5. So how do I get the 8 on its own here? Well, this goes back to one of the very first things that you learned in C programming, which was the use of the integer divide and the integer modulus, or the percent sign. If I was to say my input here, which is 895, if I say input percent 100, what that would do is that would divide 100 into 895. It would go in 8 times and would leave 95 left. Okay. Now that's not what I want. I want the exact opposite of that. But I will want that later on when I want to try to get the 9. So I'm going to have to use both of them. So instead, if I use the divide, if I say input is divided by 100, that will give me the value 8. And I can put that value through the thing. Okay. And then try and get the 9, 5 and separate out the 9. And then try and get the 5 and separate out the 5. So let's start on this. There's a few little things we'll have to consider. I'll look at the while loop and what exactly I'm going to put in there in a moment. Okay. But the first thing I want to do is I want to say input is divided by 100. And into that, or where am I going to put the result of that? I'm going to put it into num. And that's going to go in there. And then down the bottom here, after my switch statement, what I'm going to do is I'm going to say input is assigned input percent 100. That's going to leave me with the 95 that I want to use the next time. Okay. Now the problem is that the next time I come around the loop, I'm going to divide it by 100 again, which I don't really want to do. Okay. So here's where the problem starts to arise. How do I deal with that situation? What could I put in here instead to divide it by something that's going to change each time? Because the first time I want to divide by 100, the next time I want to divide it by 10, and in the last situation I want to divide it by 1. So instead what I do is I make a third integer divider. Okay. and for the moment I'm going to set that to 100. So if I put in divider here, okay, I will divide input by 100. Down the bottom here, I will %sign 100. Now, okay, I don't actually have to put this down the bottom here if I don't want to, but the DIVIDER, I could have that further up. But this next part I definitely have to have after these two. So what I'll do is I'll actually move it up to the top so we have them all in one place. So input is assigned input %divider. Okay, so that's going to leave me with the 95. Lastly, so that I'm ready the next time to change it to divide by 10, what I'm going to say is divider equals divider divided by 10. Okay, so it's 100 the first time, then it becomes 10, and then 10 divided by 10 becomes 1. So it'll work around each time. Now, in the final case, how do I know how to actually stop the loop here? So how do I know that I've gone enough times? Well, I know for the minute that this loop is going to run 3 times, but later on I may not actually know that. Okay, so rather than try and defer the problem here, we should probably think about what we should put in the while loop to actually make sure that it stops. Okay, now if my divider starts at 100 and I divide it by 10, it becomes 10. If I divide it by 10 again, it becomes 1. And if I divide it by 10 a third time, it becomes 0. Okay, because if I divide 1 by 10 and they're both integers, it'll go in 0 times. So that's really what I want to check. I want to check if divider divided by 10 is equal to 0. Or it's not equal to 0. Obviously I want it to continue while it's not equal to 0. I've written an E in there again, divider. Now, so that should stop it there at the final time. Now the only trouble with this is that in my final run I want to divide it by 1. And if I do another divide here, when I do that, it won't be equal to 0, and therefore it won't run. I'm going to leave it at that for the moment, and we'll see if we can solve that in a moment. Okay, it doesn't like this. Undeclared first use. Yeah, I've divided spelled wrong up here. Okay, so I'm not expecting this to run first time, but we'll be close on it. 895 gives me 8, 9, and it hasn't worked for the final one. It hasn't worked for the final one because on the final case, I divide by 10 and it becomes a 1. I run down to the bottom of my loop. I come back around, and before I get a chance to use that 1, what has occurred is that I've gone here and divided it by 10 to check it. Okay, so what is the best way to solve this? Well, the best thing maybe to do is to actually just have because it's only 1 off, we can just say 10 multiplied by divider divided by 10. What result is that going to give me? Okay, and in the final case, when it gets divided by 10, it'll become a 0. Okay. Actually, is there an easier way of doing that? We'll try it that way first. I have a feeling there's a quicker way of doing it, but we'll try it that way first. So 895 comes out as 895. Now I have a feeling that in the final case here, when input becomes its final value, divider is a value of 1, and we run down through it, and in the next case divider will become a value of 0. So I just want to check if this will work, because I noticed the two of them. So if divider is not equal to 0, how does that go? Yeah, and that works actually on its own, right? So because this will get done in the final case, that job is done for us. So where I multiplied it by 10 there, I could clearly see I was dividing it by 10, and those two would cancel out. So it must be that when divider is not equal to 0 that it works. Okay, just to run through this again, exactly what's happening. Divider starts off as a value of 100. Divider is definitely not equal to 0 at the moment. I take my number as an input, which is 895 in my example. I divide that by 100, and that puts the value 8 into num. Okay, that's the value that goes in here and gets printed out as an 8. However, before I move on, what I do is I take my number 895, I divide the current value of divider, which is 100, into it, and I get the remainder. So that puts the value 95 into input now. And finally, what I do is I divide my divider by 10, so my 100 becomes 10, and that's 10 that goes in there. Round I come round the loop again after printing out the 8. Divider is now a value of 10. Is that not equal to 1? It's not equal to 1, that's certainly true. So I go in here, I say input, which is 8, is now 95. 95 divided by 10 becomes a 9, and that's the 9 that gets put down through my switch statement. In the meantime, before I do that though, I say 95 divided by 10 will give me a remainder. This is going to give me the remainder of 5. Okay, so the 5 is now an input. My divider, which is 10, I divide by 10, which becomes 1, so divider is now 1. Back around, is divider not equal to 0? It's certainly not equal to 0, it's a value of 1. My input is 5, I divide that by 1, and that puts the number 5 into num, which then gets put down through the switch statement and comes out as a 5. My input, which is a value of 5, is the divider is divided into it, which goes in is a 1, so the modulus of that is still going to be 5, but that doesn't matter, I'm not going to use it again. And my divider, which is now a value of 1, gets divided by 10, that goes in 0 times, so divider becomes 0, and so the next time round divider will be equal to 0 and the loop will stop. Okay, so that works fine for number like 563. 563 comes out fine there, as we can see. So it'll work for a 3-digit number. Does it work for a 2-digit number though? And it says 002, so that's a little bit iffy. Okay, that's a single one, where it just comes in as, so as you can see, it's putting in round the things there. What about 45? It goes 045, and we'd prefer that it wasn't just putting in the 0 for those at the beginning. Okay, so our next thing to do is to try and figure out how large is input before we decide what our divider should be. Okay, now without us literally going through you know, is it bigger than 1,000? Is it bigger than 10,000? Is it bigger than 100,000? And so on, as separate if statements. What we can do is we can do a separate while loop to figure. So this is the probably the toughest part. So we'll say while and what I'll do is I'll set divider to be equal to 1, because what I want to do is I want to start divider at 1 and multiply by 10 each time until we find out what number we do need to stop at. Okay. Now, so what I'm going to do is I'm just going to pick a fictitious number like 56376. Okay, just to show you what I'm going to do here. So let's say this number comes in. I don't know how big this number is, so I'm going to have to check it. So what I'm going to do is I'm going to divide it by divider and check if the result is equal to 0. If it's not equal to 0, it tells me that the number must be bigger than 1. So what I'll do is I'll multiply the divider by 10, so that next time I divide the number 56376, I divide it by 10, and I check is the result bigger than 0. And if it's bigger than 0, then I know that the number is bigger than 0. And I continue on with that. Divider becomes 100. I divide 100 in. Is it still bigger? Yes, it is. I divide it by 1,000. Is it still bigger? Yes, it is. I divide it by 10,000. In this case, if I divide 10,000 in, it'll go in 5 times. So again, it's bigger than 10,000. Multiply it again. I'll divide it by 100,000, and I'll suddenly find that 100,000 doesn't divide in. Okay, so it'll come out as 0. Once I find that, my divider will then be a value of 100,000. And actually, I prefer to start off with the number 10,000 in order to pick out that 5 on its own. So what I'll do is, my final thing will be to divide divider by 10 again. Okay, so we'll see how that works. So while, and I'll just put up a result here. So I'll get rid of my number there. So while result not sure if I'm putting this in the right place yet, but we'll check it. While result is what will I say, not equal to 0. Okay. So result is assigned input divided by, okay, and what I'm going to do at that point is I'm going to divider I'm going to multiply by 10. Divider is assigned divider multiplied by 10. So I'm not certain I've put this in the right order yet, guys, but we'll just see as we go. Okay, so the first time through, result does not equal anything. So I think actually what I'm going to do is I'm going to remove the result. I think it's only going to confuse the issue. So I'm going to actually do the input like that. So input divided by divider. I check if that's equal to 0. If it's not equal to 0, then what I do is I multiply divided by 10 and check again and keep checking. When it does finally become equal to 0, divider will be 10 times too large, so what I'll say is divider is assigned divider divided by 10. Right, so let's give that a whirl and see how we go. So we'll start with a number like 5, and it comes out as 5. We'll start with, or we'll do our next number, we'll do a 2-digit one, 23, so that is 2, 3. We'll put in 5, 6, 7, so that is 5, 6, 7, and that's fine. Let's try something very large. 1, 3, 4, 6, 4, 3, 2. 1, 3, 4, 6, 4, 3, 2 does indeed come out. Okay, and so in effect what's occurring is that divider starts at 1, and we keep checking after we divide it by divider whether the answer is 0. It'll finally become 0 when divider becomes a number larger than the input, and once we get there, what we want to do is divide it by 10, so it then becomes the next multiple of 10 below the input number, so that we can then start to use it in our system here. So in the previous case where we had 895, we started with 100, which was the multiple of 10 below, or sorry, the power of 10 below 895. So we always want to start with a power of 10 below it, but we can't find what it is until we go one above it. Okay, and that's what our while loop is for there. So that's the full of that program. As I said, this is a very, very challenging program, and I know that most people who have achieved it over the years, it's normally taken them several classes and certainly looking for a fair bit of help as they go. So it's not by any means one that I'd expect you to get straight off or to know simply by looking at a book or otherwise. This is a significant challenge, but nonetheless, you know, if when you go on to do more programming within electronic engineering, it's this sort of thinking that you're going to have to do. There's nothing that we've seen here that's not something that you've seen before. The only difference is that you have to implement it in a different way. So you've done your while loops before, you know how to end a while loop by checking certain things. You've done the modulus, the divide, and you've done the modulus as we've seen it here. So you've done all those things. It's a matter of knowing where to use those tools to logically solve a problem that the difficulty in a question like this comes in. So take a good look at that till you see the kind of logic behind it, and but also very importantly, make sure you can start to spot how to break down a program into the bits that you can do and the bits that you can't do, because if you end up in an assessment just panicking about the size of the program, you often can't spot the little bits that you can do as opposed to the bits that you can't. And normally speaking, for most people, you know, 60% of the marks are easily achievable. With the bits of information that they know. It's the top 40 marks that are quite difficult to get, that take a lot of thinking and a lot of logic. Okay, so I'll leave the recording at that.